how to figure it out. Okay, some of you are saying 4, and the answer you can try and all to our number by which you got the link today. So let's give it a try. So if it is a 3 at the end, okay, simple 3. So 94, so it's divided by 2, remainder is 2. So 3 square. 6 to the power anything ends up with a 6. 2 to the power 89 divided by 2. So remainder is 1. And whole to the power 46. So 9 into 6 into 2 whole to the power 46. So 6 to the 8, 8 9 is 72. So 2 to the power 46. So it is actually 2 to the power 2. So this is 4. So 46 also divided by 2. So Ayush, Sudhanshu, Naman, 3 answers I got only. Rest of them are not answering. Some of them are answered wrong. So 3 correct answers. Okay. Now next one. Let me have a look here. Don't raise hands now. So we are already running late. I will give the answers at the end of the session. Okay, here we go. This question is from 2021 paper, I think. So this says that the sum of all solutions 2 log 2 x minus 2 log of x minus 2 8 in the interval 2 to infinity, sum of all solutions. This is a very interesting question. So how to find the sum of all solutions? So here let x equal to this whole thing, or rather say let x we can't take, let's take y equal to log of 2 x minus 2. Okay, so log of x minus 2 base 8, this thing will be 3 by y. So 2 plus y equal to 3 by y. If you solve it, you will get a quadratic 2y minus 3 equal to 0. So now this gives you 2 solutions. So solutions are minus 3 comma 1, isn't it? Minus 3 comma 1. So as a result of that, this will give you 2 values in the x values as well. So maybe x is 2 of 2 to the power this, so minus 3. So this will give you 17 by 8, and x2 maybe. So 4. So the sum of the solutions they have asked. So 17 by 4 by this. So 49 by 8. This was options were given, and this was the option number C. Very easy once it has been done, right? Okay, सॉल्व होने से पहले थोड़ा टफ लगता है, लेकिन सॉल्व होने के बाद तो ज़्यादा ही आसान लगता है. And remember that there will be a special session on this Friday and Saturday as well by Professor Chatterjee, so where you can ask questions and all. And in the meantime, you can send me the doubts to the WhatsApp number is provided so that I can forward it to sir. So in the meantime, if sir gets any free time, he can solve it. So class में आप लोगों का जल्दी से हो जाएगा क्योंकि 1.5 घंटे की क्लास में सब कुछ कराना थोड़ा मुश्किल हो जाता है. Okay. Next. So how many squares are there in a 16 into 16 matrix system? So the formation is whenever you have a, so you are actually finding square within a square. So it's a square within a square. Formula is 1 square, 2 square, 3 square, but till when it will go? 16 square. So formula is n into n plus 1 into 2n plus 1 by 6. N equal to 60. I hope you can do it from here. So 16, 17, 33 and 6 and finish it off from here. So my pain point will be today to give you the idea of the questions, how it is being done and how quickly you can solve it. There is another question from 2020 paper. So this is ABCD are real numbers. The maximum value of Cx plus dy they have asked over all points on the ellipse must be, so the value of Cx plus dy over all the points of the ellipse must be what? And the options are follows as, give it a try. Okay, so basic elliptic structure. So for this we will use a inequality pattern. Remember that in this kind of inequality are two types. One is AM greater than equal to GM greater than equal to HM inequality, which is also mentioned as A plus B by 2 greater than equal to AB whole to the power half greater than equal to N of AB. Sorry, 2AB by A plus B. So this is the HM. Same thing here we can apply, but here we will be applying with a different inequality that is called Cauchy squares inequality. So in that case, Cx plus dy, this thing, okay? So let's put it like this, AC into x by a. So this is Cx only 2 extra a I'm putting because these patterns are either AC or AB, AC or AB. So I need to go by that options, VD y by b. This is less than equal to a square c square b square d square according to Cauchy squares inequality into root over y by b square. Okay, so here this thing is equal to root over a square c square plus b square d square. Again, if we take now for taking x equal to a square c divided by root over square d square and y equal to b square d by b square d square. Okay. So if this thing we take, then cx plus dy from this thing we can write a square c square plus b square d square. Okay, so maximum possible value is this thing. So that is option number A. Here. See, these questions were not at all tough, but how the approach is, that is very important. There was another parallel question, let me show you. That they given as 1. And this is a particular ISI pattern. So 1 plus 2 plus 3 dot 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 2021. It came in 2021 only. So can anyone give it a try and solve it to me? The options are 2021 by 1010 or 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 so this part. Sum of the first n natural numbers is n into n plus 1 by 2. That's for sure. So what will be the ending part? Let's talk about this thing. So 1 to 2021. So this is 1 plus 2 dot 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 in that way. So all in reverse. So this is 2 into n plus 1. That is equal to this 2. Let's put it outside. That is 1 into n plus 1. Okay, 1 into n plus 1. Then again, put this summation, and this is n plus 1 minus n by n into n plus 1. This we can do. Now for this thing, 2 summation of 1 by n minus summation of 1 by n plus 1. So 2 summation of 1 by n minus summation of. So if I take 1 to 2021 minus 2 to 2022. Divided by 1 by k. So finally, if we proceed in this way, so this thing will be 1 minus 2022. So finally, it is 2021 by 2022 into 2. Again, I think option B is answer. So just a summation structure, basic. We put a valuation change, and the answer is directly in front of. Next. fx is this. Now, how many sign changes are there? So, sorry. So they tell that find the difference between real, positive, and imaginary roots. So can you find it from here? Give it a try and tell me. You can apply Descartes' rule of sign. Those who don't know, I will teach you, don't worry. Oh. Send it to me through that WhatsApp number, please. Okay. Two correct answers. Here I'm seeing. Okay, one question
Sir,
I
which
have.
number, sir?
96745 The number from which you get the class related messages. This number. Okay, is there been any improvement in the video quality you can see? Anyone who are seeing, especially in the video where you can see me, or it is like the normal day-to-day previous one?
So it is better, more clear.
Hmm. Okay, enough time provided. Let's solve it. Descartes' rule of sign is just write the function fx in this way. Powers must be from ascending to descending. And you see that what is happening. So how many sign changes? First is a plus, plus, plus. First sign change this to this. Then minus, minus, then minus to plus. Second sign change. Then plus to minus. Third sign change. Then minus to plus. Fourth sign change. So positive. So in fx positive or x plus, whatever the sign changes, that is a positive and real root. 4 real root. Now let's take f of x minus x. So that is minus 14x to the power 7 plus 8x to the power 6 plus 7x to the power 5 minus 4x to the power 4 minus 15x cubed plus 8x squared plus 9x plus 5. Here. So this is with f minus x. How many sign changes you can see over here? 1, 2, 3. Three sign changes. So 3 real negative roots. So 4 plus 3, 7. And total roots are 7. So imaginary roots are 7 minus 4 minus 3 equal to 0. So no imaginary root. So find the difference between positive and imaginary root. So positive roots are 4, imaginary roots are 0. So simple answer is 4. Now let's do another one, 7. The polynomial is given. Okay. Has at least one real root. If and only if there is IFF, which of the following is true? Give it a try again.
Can you explain the option?
Just send it to me.
Sir, what is the first one option?
C less than 2. Just think about the above part and proceed. Okay. Has at least one real root. First example, here you see this. No sign changes here. Okay. So one thing for sure, there won't be anything in greater than. But fortunately, that options are really hard here because C can be any negative number, right? If you can give a negative number, then one sign change they can say. Even if you change it to be negative, for example, x4 minus 4x, let's C is a positive number, 1, 2, 3, like that. So in that case, this to this one sign change, this to this two sign change. In other case, one sign change. Okay. So we cannot be sure about the position of C because C less than, greater, less than equal to 2, less than 3, less than equal to 3. In order to make it C negative, all 4 are correct. So we can't go it in that. Okay. So how to do this? So remember that if we take an equation, for example, x4 equal to a minus 4x, where a equal to, if we take minus c. Okay. So consider the value of a. So y equal to a minus 4x if you take, and it touches the y equal to x to the power 4 line. So x0 equal to the common points, then derivative of the function is minus 4x and x4 equal to x equal to x0 point. So minus 4 equal to 4x0 cube. So this is, these two are gone. So x0 equal to minus 1 or minus 1 to the power 4. So a plus 4 equal to, so this thing is a plus 4. So from this thing you can get a plus 4 and a equal to minus 3. So when a greater than equal to minus 3, so the curve y equal to x to the power 4 and y equal to a minus 4x, these two curves will intersect. And that is only possible if c less than equal to 3. So this is the answer. So sometimes Descartes' rule of sign also falters if you have to find it in this way. But in Descartes' rule of sign, I am telling you another special thing, special form of Descartes. See, I am writing Descartes, S is silent actually. For example, if you get a combination from a function fx equal to x to the power n ax to the power n minus 1 in that way, that the positive, negative and imaginary, maybe 8, maybe 5, maybe 2. So this is the condition. But now this will go down. This is the maximum real and negative. And this is the minimum imaginary. Whatever the first part gives you, that is minimum of the imaginary, maximum of the positive and maximum of the negative. But they can go down in couples. Go down in, for example, it is 6, then it is 5, and this will go 4. Remember that the total cannot change. Still 15. This is 4, 5, and 6. So I'm reducing 2, and that 2 is going to be add here, not to the negative. Then 2, 5, and 8. Then 0, 5, and 8 is another combination. Even after, alongside that, I'm showing in a separate way. You can show it in a together way as well. Then 0, 3, and 10 is a combination. 0, 3, and 10 is a combination. Then 0, 1, and 12 is a combination, but this cannot go for like 0, 0, 13. This is a not possible combination because this will only fall in couples. If it is an odd number, 1 will left. If odd number, then 1 will be left out at the end. Next one. Again, algebra based question. The number of different values of A for which the equation has two identical real roots. Is it 0 or 1 or 2 or 3? Think about it. Can apply normal algebra, can apply extended functional system, or apply Descartes' rule of sign. Let's see what you can do. Waiting for your answers. Hmm? Okay. So let I be the value of the identical roots, or if the two identical roots they have given of the equation x cube minus x plus a, and third root is maybe b. So x cube minus x plus a is x minus I whole square and x minus b. 2ix plus I square. X minus b, so x cube minus x square, 2I plus b, x 2I b plus I square b. Okay, so comparing the coefficients, we can do that. So 2I plus b equal to 0 and b equal to minus 2I. So 2ib plus I square, this thing equal to -1, and I square equal to 1/3, I equal to plus minus root over 1/3, b equal to minus plus 2 by root 3. So a equal to minus I square b, that is plus minus 2 by 3 root 3. So answer here, okay, I have not given you the option this time. So this is the answer. So finding the imaginary root from this. Okay, so two identical real roots, 0, 1, or 2 or 3. So this is what? How many values? 2 values. The answer is 2. Option number B. No, 0, 1, 2. So option number C. Nine. Find the last two digits of this thing. Okay, see, 1 factorial starts with 1, 2 factorial means 4, 3 factorial is 6, 4 factorial is 24. This is 120, 720. This will keep on continue till you get last two zeros.
Sir, 2 factorial value is 2, no sir?
Oh, yeah, sorry. 7 factorial is, what is 7 factorial? 5040. So in that way, why I'm doing it? Because after a certain point of time, I will don't have to do it. Okay, 5040 into 8 factorial is 40320. 9 is, just multiply 9 with this. Okay, so that is 36280, and 10 factorial we don't have to do it because this will end up with two zeros. Okay, so 3628800. So that is a thing now. So all you have to do is add the last two. So here we have 01, 02, 06, 24, 20, 20, 40, 20, 8000. After that, 11 factorial or till 2022 factorial all ends up with a double zero. So that doesn't matter. All you have to add is and get your answer. So tell me the answer now.
Sir, 13.
Okay. Everyone got 30, so I'm not doing it anyway. I think this much subtraction, addition you guys can do. Okay. This question is again from past ISI. A be a real number and consider the system x plus 2 square equal to 0, where R is the set of real numbers. For what values of A, the equation have exactly one double root. Options are so let fx equal to this thing. Forget about this part. Only try to draw the diagram here. In the graph class, I have told you everything, so I'm just going to give you the diagram directly. -7, this is -2 for sure, because x plus 2 and x minus 2, so these two things, if you put these two values here, so this will be the quite the diagram. Okay, and this is x equal to 0.8, and this is -9/2, so that is -4.5. Okay, this will get it by after a basic derivative. So if we do the f dash x, so 2 into x plus 2, x plus 7 squared plus 2 into x plus 2 squared, x plus 7. So similarly, 2 into x plus 2, x plus 7, and 2x plus 9. So if you equate them with 0, f dash x will equal to 0 gives you 3 points, -2, -7, -9/2. Once these are there, so value x y equal to -9/2 is the root of the equation. So if we take it like fx equal to f of -9/2, this is 5/2 whole to the power 4, that's a real. And this is the only double root. So this thing. Remember that this is not the answer. You have to put it with respect to minus, because you got it as x plus 7 equal to 0, 1 is, for example, x plus a. So obviously the last part plus thing plus a. So a equal to this. If this thing is equal to minus, then only it will be cancelled out. Next one.
Excuse me, sir.
Yeah.
So what is the meaning of double root?
Double root means same value twice coming. 5 in that. Next is this came actually as a subjective question.
Sir, so what is the answer?
A equal to -5/2 whole to the power 4. Next is a function-based question here. F and g are real value differentiable function. F of g of x is x, and f dash x is 1 plus f of x squared. Give it a try for this one, please.
Can you repeat the question?
Yes,
Can you repeat the question?
this is given directly. This is it. If this f of gx is x, and f dash x is this, then g dash x is what? So function of a function structure given. Right. And it tries. Okay, you can see some. Mhm. Okay, here we go. So this, if you differentiate outer side, g of x, g dash x equal to 1. G dash x 1 by f dash of g of x. So 1 by 1 plus f of g of x square. So that is again x, 1 by 1 plus x square. So the first option is the right. Next is $64 players, a group of 64 players. In a chess tournament needs to be divided into 32 groups of 2 players each. How many ways? Very direct solution. $64 players. Remember that. So total 64 per ways to select. So the total permutations. And the group of first two, second two, first two, second two, third two, and so on. So there are group of 32nd two. But inside each group, 2 players can get permuted into 2 factorial ways. 2 players. In 2 factorial ways. So 64 is the total cases, and the repetitions are 2 to the power. This is since the group can be interchanged and divided by 32 factorial. Okay, so here let me just write it. 64, 32 factorial, and 2 to the power 30. These are the total possible ways. Next, number of real solution. This question we have done previously as well. But still, it again crosses our path, so I will be solving. How many real solutions? 0, 1, 2, or 3. Remember that if I tell you that e to the power x equal to x, then it has no real solution. Why? Because these curves will never intersect. Okay? The curve has to intersect with each other. Otherwise, we cannot say. So here in this case, and in a normal way also think e to the power 1 not equal to 1, e to the power 0 not equal to 1, e to the power infinity is infinity, that is also not equal to this in that way. So if for any finite value, e to the power minus infinity is also 0. So for any finite value, this thing is never, because e equal to 2.718 dot dot dot. So think in this way and tell me the answer quickly. Okay, okay. This approach, Karan, is wrong. Okay. e to the power x from 0 to 1 for all values of x less than 0 lies this. So on this segment, so we get 2n pi by 2 to 2n pi. So this is the segment where n less than equal to minus 1. So the function sin x increases from 0 to 1. Hence, there will be one intersection point. Okay. Now, sorry. 0, 1, 2, 3 is the wrong option answer I've given. It should be 0, 1, 2 and infinity. Okay. It is actually given, I missed it out. So 0, 1, 2 and infinity is the option. So obviously, this curve of the sin x is like this. And it will be infinite number of times this intersection will happen. Okay. So that's it for today. So this is the assimilative part. Tomorrow there will be another session at so what was the let's just let me check, I forgot. No, Friday I think no session. Let me check. Okay, I'll try to give a Friday session with you. I'm not sure, but Saturday session is sure at 8. We'll be informed about this tomorrow. Okay. Thank you. And the PDF, I'm sending it to you right away.